All right, everybody. Hope you are doing well. This is going to be kind of randomly thrown into the end of this unit. Usually do arithmetic and geometric together, but we're only doing geometric right now. So a geometric sequence. What you need to know is that for something to be geometric, you're going to multiply by a number to get each an x term. So 2, then 4, then 8, you're multiplying by 2, so on and so forth. You're not adding, you're multiplying. If it was arithmetic right here, oh, why is that zooming in crazy? So geometric, you're gonna multiply everything. Arithmetic, you're gonna add. So adding a negative or multiplying or dividing, that's the same thing, because dividing is the same thing as multiplying by a fraction. So your geometric sequence formula, when we're looking at this, your geometric sequence formula, some notation you're gonna have to see, g sub n is gonna equal g sub 1 times r to the n minus 1 power. So this is whatever number of term you want it to be. Let's not call it that. So this is your term. G sub 1, it's got a 1 as a subscript, so that is always your first term. R is going to be what we call the common ratio. So that's going to be the number you're dividing or multiplying. And n is the number of term you're trying to find. So we'll get to that when we get more into the explicit rule. So let's take a look at this. Are these little sequences, so see a sequence, man, we're behind on. Plain and simple, it's just a list of numbers. A list of numbers. So to see if these are geometric, arithmetic, or neither, or something else, we got to look at these. So to get from 2 to 4, we can add 2, or we can multiply by 2. To get to 4, from 8, we can add 4, or we can multiply by 2. So I see it as not arithmetic. Could it be geometric? I keep going. Yes. So this is an example of a geometric sequence. That's kind of how we're looking at these. So if I come over here to the second one, I like to do it up top. So my arithmetic, I always check up top. Geometric, I check on bottom. So I'm going to add 2 times 2. Add 2, not times 2, so it's not geometric. So this is arithmetic. All right. So kind of looking at this too, to get from 4 to negative 12. If I've checked arithmetic, geometric, 4 from negative 12, I'm going to subtract 8. And then to get from 12 to negative 36, I'm not subtracting 8 again. So we're good to go. This we're timesing by negative 3. Multiply by negative 3. Negative 3, so this one is geometric. Kind of looking at these. Arithmetic or geometric, so I'm adding 1. Adding 1. Not adding 1, so it's not arithmetic. Times 2, not times 2, so this is your example of a neither. It's got to do it the entire time for it to work. So if it changes, that's why I stop once I see one that changes. And we're good to go here. So here I'm subtracting 2, I'm adding 2, so not arithmetic. Times 1, or sorry, negative 1 times negative 1. So this is actually geometric, because each time you're multiplying it by negative 1. All right, so let's take a look at this. Let's write an explicit rule for our geometric sequences. I'm not going to do recursion, so we're not going to do that. We're just going to do explicit. So to write an explicit rule, remember our formula up at the top is g sub n is equal to g sub 1 times r to the n minus 1. So to find your r is your common ratio. So it's going to be g2 over g1. So in this case, my r, this is g1, this is g2, this is g3. So 6 over 2, so my r is 2. That'll help you out. So what that's saying here, that my r is 2, that's saying each time I'm multiplying by 2. And that's what I'm doing. So if I'm writing an explicit rule, so I could put this in this box. So if I'm writing an explicit rule, so g sub n equals g sub 1 times r to the n minus 1. We're always going to leave G sub n, and n alone. It's kind of like your y and your x. G sub n is kind of like your y, and n is kind of like your x. So all I need to find is my G sub 1, which is my first term, and my r, which is my common ratio. I just showed you r is equal to G sub 2 over G sub 1. So to write my equation, G sub 1 is my first term. So I got 3 times 2 to the n minus 1 power. And there is my explicit rule. It's just practice. I know this is strange. It's new. Usually we do arithmetic and walk through a lot. But this year we're doing something different. So it's okay. All right, here. Same thing. So G sub n equals G sub 1 times r to the n minus 1. G sub 1 is easy to find. G sub 2, G sub 3, doesn't matter unless you want to keep check it. So to find my r, remember it's G sub 2 over G sub 1. So negative 7 over 42. If I reduce this, that's negative 1 over 6. And you can see if I multiply 7, or negative 7 times negative 1, 6, you get 7 over 6. So you're good to go here. So G sub n equals G sub 1, which is 42, times negative 1/6 raised to the n minus 1 power. And you got your formula. So what this does is now that you have a formula, you can find any number of term that you want to. If I want to find the 7th term, all you got to do is plug in the number 7 for your n, and you can get the 7th term. If you want to find the 5th term, you plug in the 5 for n, and that will allow you to get your next term. So here, these last two, a little bit different. We'll figure some things out. I'll show you how to work through these. So given 2 terms of a geometric sequence, we're going to write the explicit rule and give the 8th term. Okay? So a little bit different, but we're going to do 2 different things. So first, let's take a look at this. So here, I got my 4th term, which is a sub 4. You can change it to a or g's. I like g's when I'm talking geometric. And then I have a sub 5. So if I'm looking at this, I know by looking at this, r is equal to negative 6 over negative 12. It's kind of like G sub 2 divided by G sub 1. As long as you have 2 next to each other, you're good to go. So my r is equal to 1/2. So G sub n equals G sub 1 times 1/2 raised to the n minus 1 power. That's what I know. That's the easy thing I can find out. Now, if I take this a sub 4 and I plug it in, that's telling me that the 4th term is negative 12. So if I plug this in here for my G sub n, I have to plug in a 12 for my n. So those go together, or sorry, not a 12, a 4. Sorry. Because if my n is 4, what this is saying here, where it's boxed, if my n is 4, then my solution, my 4th spot is equal to negative 12. So now when I simplify, so negative 12 equals G sub 1 times 1/8. So I'm going to multiply both sides by 8, so G sub 1 is going to equal negative 96. Now I have enough information, so G sub n is equal to negative 96 times 1/2 to the n minus 1 power. So I have my explicit formula here. And if I want to find my 8th term, so just some notation, G sub 8 means I'm finding my 8th term. And I can plug it in. So negative 96 times 1/2 to the 8 minus 1 power. So negative 96 times 1/2 to the 7th. And G sub 8 is going to equal negative 3/4. You type it in your calculator. So that is what we're going to be doing. So kind of practicing with these, working through it, and we're good to go. Now, let's come over here with B. I have 2 that are not in order, and I'm skipping something, so I got to kind of look at it. And this is not going to be quite easy. Okay? So what I have, if I'm kind of taking a look at this, I got my first term, I got my second term, I got my third term, which is 108. I got my 4th term. I probably should have done this. I'll slide this over. Just give me some space. Man, I'll So 108, 3,888. So I need to find the R. What am I multiplying by 108 to get the blank, to get 3888? So on and so forth. I can kind of look at this. A trick to look at this, if I look at these three as my first three terms, I can solve this using my formula. So if I'm looking at this, G sub n equals G sub 1 times R to the n minus 1. If I'm just looking at those three, if I say 3888 is my third term, 108 is my first term, I don't know my R because that's what I want to find, but I know my n is 3. So I can solve for my R if that's my only variable left. So if I take 3888, divide that by 108, you get 36, not 306, equals R squared. So R here is equal to plus or minus the square root of 36, which is 6. Okay? So that helps me out here writing my formula. Because now I can write my formula. So G sub n equals, well, maybe I can't because I don't have my G sub 1. I need to find that. So if I find that, so if I'm taking this, I can multiply by 100, I can take that 108, if you kind of fill in the gaps, times it by 6. So this one could be plus or minus 648. So if I multiply it by plus 6, I get positive. If I multiply it by negative, because I'm multiplying, I can. If I go backwards, I can take 108 and divide it by 6. So this one could be plus or minus 18. This one would just be 6 because it could alternate. If I'm multiplying by, I don't know why 6 is 3. So I'm dividing by 6. Because if it's a negative R, every other one's going to be negative and it goes back to positive. So I know my G sub 1 is 3 times R. You can have it plus or minus 6 to the n minus 1 power. So you could have either form. If you just want to keep it positive for making it easy, you're more than welcome to. But you see how every other one would be negative. So now if I want to find the 8th term, G sub 8 is equal to 3 times, we'll just keep it 6 to the 8 minus 1. So G sub 8 is equal to 3 times 6 to the 7th power, and you're going to get a huge number. So the 8th term here is 839,808. And you got your answer. So make sure you're practicing these. Look at these couple examples. These are the hard ones you're going to get. As long as you know how to find the R and write a formula and how that formula is applied, that will help you out tremendously. Tomorrow we're going to get into series, so a little bit more in depth. But take this as you know. If you got questions, let me know. Other than that, make sure you practice these. The more practice you can do, the better off you will be. So other than that, have a wonderful day, and I will talk to you later.